A very good evening to you all. Today we will be having the third session of the Enigma workshop series. I hope you have found the past two sessions valuable and enjoyable. Today your mentor would be Windu Athakorala from the 22nd batch Computer Science Engineering Department, and he will be teaching you about data structures. Also note that we will be giving 500 rupees reload as a gift, which you can get by properly answering the questions that are given to you. And without further ado, I would like to invite Windu Athakorala to take over the session. Thank you.
Thank you, Lampurnan. So, good evening to you all. I hope you enjoyed and learned something new in the last two sessions. I am truly excited to be teaching you today at this workshop number 3, and I hope you will learn something for your life. So today, before we start anything, we will do a small recap of functions. Well, functions are something that is a part of Python that is very useful and help us do a lot of things. And they have been taught to you during the past session. And today I will just go through a small recap of what you learned last week. So, as you know, a function is a block of organized codes that performs a single related action. It belongs to the subprogram control structure and helps us modularize our program. For example, imagine you have a complex algorithm which you have to use many steps to solve a problem. Well, this code can be messy, involving about 1,000 lines of code. And maybe you are using many lines of code you are using the same line of code in many places. Well, this is where a function comes in. You can simplify your code by defining these commonly used code lines of code. That you can define the commonly used lines of code as a function and easily reuse them over and over again by just calling them when you need. So this is one of the advantages of functions. So moving on, function arguments. So when you're implementing the function, you need to have some inputs. So these are what function arguments are called, and they can be passed into the functions as arguments. And you can add as many arguments as you want, just you have to separate them with a comma. And we have done a few examples for you last week, and you can see one on the screen now as well. So next, you know that the function takes an input that was there in the previous slide, where the function also gives you an output, and that is done with the return statement. So you know the return statement is used to end the execution of a function call and returns the result. So an important fact to note is that the statements after the return statement are not executed. So I repeat, the statements after the return call is not executed. And this is very important because while functions can also modularize your data, your code, it can also serve as a way to quickly exit a certain loop if necessary. So imagine you're in a program where you need to have about 3 or 4 for loops. So if and using these 3 or 4 for loops, your program finds a solution that you require. Well, then your program won't need to run the remaining for loops again and again. You can simply exit. But this is a bit complex when just using for loops. So what you could easily do is use these for loops inside a function and program your function to return the answer as soon as the solution is found. So this is so the return statements are an easy way to exit multiple for loops or exit certain processes that would be difficult using simpler coding statements. So next, we have an important part when we are dealing with functions. This is the state of the variables, mainly global and local. So inside a function, we have an environment where any variables defined inside a function are relevant only to that function. This helps us, as I mentioned before, separate this function from the rest of your code, making sure that there are no leaks that are not desired. So the only inputs to your function will be the inputs or the parameters for your function which you put in, and the only outputs will be those which are returned by the return statement. So this is where these global and local variables come into play. Local variables in Python are those which are initialized inside a function. So they belong only to that particular function. For example, if you define a function, if you define a variable inside the function called a, and if you try to use a outside of that function, you will receive an error. That is because you are trying to use this variable outside the scope that it is initialized in. Well, on the other hand, global variables encompass all these functions. So global variables are those defined outside a function and are accessible throughout the program. So if you define a global variable outside your function in your main program, you can use them anywhere inside the program, even inside the functions. So this is something that is very important to note. So if you want variables that are only used inside that function. For example, let's think we have a huge program which has additions, multiplications, subtractions, etc. So you can have separate functions for additions, subtractions, and multiplications. And you can define variables only inside those functions so that they will not be used later outside of the functions. So I think that is it for functions for today. And we'll also just one more slide that we have to add is the global keyword. The global keyword is used when we want to change the value of a global variable or assign it a value inside the function. So as I mentioned, although you can access global variables inside the function, you cannot change their values. So in order to make sure that any change we make inside the function is permanent, we have to define this variable as a global variable and use the global keyword. So now we will move on to today's topic, data structures. So during the past 2 weeks, you have learned a wide range of data types. So I would like you all to mention the data types that you have learned during the past week in the chat. So Hansini has replied with strings. Yes, strings is one of the data types used very often in Python. Januda has replied with strings, Boolean, integers, and floats. Yes, very commonly used. Again, all of these are very commonly used data types. And also, yes, I think, yes, Adipa has mentioned data type not mentioned before, complex. Yes, yes, you can specify complex with the real and the imaginary number. Well, a few of you guys have mentioned list, dictionaries, and tuples. Well, the question is, are they data types or are they data structures? Well, actually, that's what we are going to teach you today. So these objects called lists, dictionaries, and tuples are data structures, and they make life much easier for us Python programmers. So imagine if you have a complex program where you have to work with a vast amount of numbers. For example, let's take uh, a data collection app where you where you collect data of all of the people's weights. So for it's some healthcare app. So in such a scenario, you'll have to deal with a large input of numbers. So do you think it would be feasible for the program or the programmer to write code declaring a variable? So let's think it is person one's weight. So do you think he will have to declare a variable person one, weight of person one, weight of person two, and so on? Well, you know that this would be a waste of time and a waste of resources. So that is where data structures come in. They help us to handle large amounts of data in structured ways so that it becomes easier for us to write code and do whatever processes that we need to do. So can any of you all, so I think a few of you have mentioned a few data structures. So uh, can you now can you put in the chat the different data structures that you may know, the common ones? Just mention a few of the common data structures. Yes. We've got lists, tuples, sets, dictionaries, and yes, I think Rusiru is mentioning some complex data structures, linked lists, hash maps. Yes, those are a bit out of your scope, but you can learn them online. And if you need, you can just send me a message, and we will help you with these advanced data structures. But today, what we'll be teaching you is lists, sets, and dictionaries. So these are some of the most commonly used data structures in Python, and you will see how easy they make life for you as a Python programmer. So let's move on to the first data type, which is lists. So going back to that example I used, imagine you have to take inputs of different people's weights for a certain healthcare app where you have to calculate the BMI or etc. You will have many different inputs. And how are you going to save them? Well, a list would be a feasible option. So lists store multiple items in a single variable. The list is the most versatile data type available in Python and can be written as a list of comma separated values between two square brackets. So items in a list do not have to have a same type. This is something that is very important that we should remember. In a list, we don't have to have items of the same type. So for example, you can have a list as mentioned above as 1, 2, 3, 4, 5, which are all integers. But you can also have a list which comprises of integers, strings, other lists. So you can also have lists inside a list, which I will teach you later on. So just remember that lists do not have to have the same type inside them. They can have different types of data all at the same time. So you could have a list which has one, your name maybe, and a date. So it can have a large variety of data in them. So list items are ordered, changeable, and allow duplicate values. So this is something that we again have to remember. They are ordered. So it means that when you declare a list and when you have items in the list, you can access them according to order. They are not random. So if you want to access the second element in the list, you can do so. If you want to access third, you can do so. And the order won't change unless you specifically change the order. Then again, lists are changeable. Can anyone mention a more commonly used term for changeable? What do we say when we say lists are changeable? What is this? Yes, Manodia has answered correctly. Many of you actually have answered correctly. Lists are mutable. So this means that during the program, after defining this variable, we can change it the way we want. So for example, in this list that we have above, 1, 2, 3, 4, 5, imagine you want to change a variable. You want to change one of the items of the list. So uh, we can just change it any way we want. And I will show you how we can do that in the slides that follow. So, and also another important point about lists is that we can have duplicate values. So we can have we can have a list of 5 ones or etc. And these are a few points of lists that make them different from the other data structures that you will learn. So also remember, as I mentioned before, lists are ordered and therefore they have an index. They are indexed. So the first item has an index of 0 and the second item has an index of 1. So lists are 0 index data structures with the first item starting with 0 and the second item starting with 1 and so on. So if you want to access any of the elements in the list, you would just pass in the list and mention the index of that uh, uh, particular item. So you can see a few examples for lists, and I will give you a uh, few seconds to just type them out because we will be using these lists going forward, and I would like you to do it along with me. So I would like you to work on these lists along with me while I teach you different functionalities of lists. So please just type at least the first 2 or 3 lists on your own computer, maybe on idle or certain or any other IDE that you use. And could I see a raise of hands once when you guys have just typed out a few of these lists on your own personal uh, computer? Again, let me repeat, just copy down these lists, save these lists as variables, and just raise your hand so I can see that you have done so. Mhm. Okay, Adipa has is done. Could a few more of you all please raise your hands? And if someone who did it, if you can share it on the chat, that would be really great. So maybe then they can just, the rest of them can copy down your code. I'll give you another minute, and could the rest of you also raise your hands once you guys are done saving these lists as variables? Mm. Okay. So now let's begin with manipulating or using these lists in different ways. So you can see a few list operations. So last week and the week before, we taught you a few operations for other data types. So could you mention the uh, integer operations that you have learned last week? Uh, just mention the integer operations that you may have learned last week. You can just send it on the chat. Well, so we have stuff like addition, multiplication. So these are all integer operations. Comparison. Then you have yes, division. You have the modulo operation. You have the integer division operation, certain operations that help you manipulate lists. So can you all mention a few string operations that you may have learned? So yes, we have different string operations as well, where we have concatenation, uh, uh, string, uh, we have addition of strings. Then we also have uh, different functions we can use with string methods. So similar to those, we also have list operations. So these are a set of functions or methods that help us to uh, manipulate lists in order to use them efficiently. And so let's begin going through these operations. So we'll start with concatenation. So what is list concatenation? That means it is something similar to adding two lists together. So you can see this example, list 1 and list 2, and we can have a result which is list 1 plus list 2. And you can see by just using this addition operator, we can combine these lists together. So just important to note, what we do with the addition operator is not add the elements together, but instead add the two lists to each other. So you can see this output that is on the screen, and you can try this with the lists I've given you. So just add maybe list 1 and list 2 or any of the other lists that you all have, and you all can play around and see the results of using this concatenation operator. So if you tried it and it worked for you, you can also raise your hand. If anyone is receiving an error, you can just send me a message mentioning the error you got. So if you're done just trying out this list concatenation, just raise your hand. And we will move on to the next function. Okay, so quite a few of you all are done with uh, this list concatenation. Now let's move on to the next feature of lists, and that is repetition. So just like we use the uh, uh, addition symbol to add two lists together, we also can use the multiplication operator to multiply a list, multiply the elements in a list many times. So you can see here, when we have list 1 with the elements 1, 2, and 3, by multiplying list 1 by 3, we can get a new list which has 1, 2, 3 repeated 3 times in a row. So again, I will give you a minute to try out this operation, and raise your hands once you guys are done. So you can see how easy it is to work with lists. So yeah, imagine if you were trying to do this by yourself, typing 1, 2, 3. I mean, even 3 times is all right, but imagine you need a list with 1, 2, 3 repeated 100 times. It would be very tedious and very time consuming to type that out by hand. So these list operations make life really easy for us programmers. And you can also try these out in different problems that we give you over the course of this Enigma competition. Okay, so you can raise your hands once you guys are done. Okay, very good. And now let's move on to the next, and that is the membership test. So another thing that is important when we are writing programs is to check if a certain item is in a list. So, for example, we have a list which contains all the students in a certain class. And now we want to check if a certain student, maybe called Nima, we want to check if Nimal is also in this class. So if it's a class with 30, 40 names, it will be annoying and it will be a waste of time to read through all these 40 names. So instead, we can use this membership test in lists. So we could just type the element you want to check and the name of the list. So you can see the syntax given below. So you have the list and you type the element. So here we want to check if 3 is an element of this list. And what will be returned is whether it is in the list or not. So true for if your element is in the list, and false for if the element is not. So now I will give you another minute to try this out. So like using the list that we had used before, you could maybe try if is orange in list 1 and see what you get as the output, or is uh, or is raspberry in list 1 and see what the output is. Also, another interesting point is that if you try to use a string and maybe if you want to check in list 3, so list 3 is 1, 5, 7, 9, and 3. So if you try and check if 3, which is a string, so 3 within double bracket within apostrophes, if you check if the string 3 is in list number 3, well, then you receive an error, because what we have in list 3 are numbers, are integers. So we have list 3 comprises of 5 integers, but if you check if the same integer as a string is in the list, it will return false. So always remember that you have to check with the data type as well, the correct data type. So just because you check for integer 3 and string 3, it will be it will not be equivalent to each other. So once again, I think if you are done, please raise your hand. Okay. Then next, let's move on to indexing. So now when using lists, when using massive lists, we come across the question, how are we going to access these elements? So this is also something that we would need a lot when using large lists where we cannot just identify which identify individually. So if we want to access the third element, we should have an easy way to do so. So that is where indexing comes in. So if you want to access the third element, you know that you have to find the index of the element in the list. So as I mentioned before, Python lists are zero index. So they start with 0. The index starts with 0. So can someone mention what the index of the third element in a list would be? What would be the index of the third element in a list? Yes, very good. Manodya has mentioned that it would be 2. So always remember, if the index of an element in a list is 1 minus its position, that is because all lists in Python are 0 indexed. So if you want to access the third element in a list, all you have to do is list, type the name of your list, and specify the element, the index of the element within within square brackets. I'm sorry. Just specify the index of the list of the element within square brackets, and you can see this in the third line of our example. So what they've done is saved element 1, and they wanted to get the first element of the list, and they've specified list1 square bracket 0. Well, next we come, so now that you understand indexing, how do we get a range of elements? So you can get a range of elements by just specifying the range. Similar to indexing, if you want many elements, you can just specify the range. So how you would do that is you would specify the starting rate, the starting element, and the element after the ending element. So if you want, for example, if you want the elements from 1 to 3, so if you want the elements from index 1 to 3, what you would do is you would first mention the index of the starting element that you need, and then you mention the element after the ending element that you need. So since we need elements from index 1 to 3, what we do is we put 1 within the square brackets, followed by a colon and 4, which is the index after 3. So I will give you another minute to try indexing and slicing. So these are very useful ways where you can access and use elements inside lists in Python. So just try indexing and slicing, and let me know if you have any errors, because when indexing and slicing, sometimes we come across errors. For example, if you give, let's think our list has only indexes from starting from 0 till 5. If you try to access the 6th, if you try to give 6 as an input for the index, you will receive an error. You will receive an index error, because there is no such element with index 6 in a list. So always remember, you will always, if you do not give a correct index, you will receive an error. So always specify indexes which are within the list, which are with elements which are present in the list. So just raise your hands once you guys are done playing around with indexing. Okay, so I think we're done with list indexing as well. So next, let's move on to length. So this is a very simple function. This is just getting the length of the list. So all you have to do is first type in the length function and then put in the name of your list within the length function, and that will return to you the length of the list. So you can try this at home. It's not something very complex. Just put in the name of the list within your length function and you will get the length of the list. So next you have append. So what happens if you want to add a new item to the back of your list? So this is where we use the uh, append function. So it's actually a list method. So you type the name of the list and then dot append, and within brackets, within parentheses, you specify the element that you want to add. So you can see this being done in the example we've given you. So I will give you another minute to try it, and please raise your hand once you're done with list append. Again, list append is a way that you can use to add a new element to the end of your currently existing list. So all you have to do is type in the name of your list, dot append, and specify the element that you want to add within parentheses. So next we will move on to insert. So insert is something similar to append, but what if you want to insert something in between elements at a list at a specific position? So what append does is it inserts the element at the end of the list. But if you want to insert it in the middle, all you have to do is similarly to append, but you have to specify the position you want to insert the element at the list. So for example, here we want to insert the element 5 at index 1. So we first mention the index, next we mention the element. And you can see that 5 has been inserted in at the first index of the list. So remove also is something similar. So what remove does is it just removes the element in the list. It actually removes the first occurrence. So you can see the example given below. We want to remove 2 from the list, and we give 2 as the input to the remove function. And you can see that the first 2 that occurs at index 1 has been removed. So why hasn't the other 2 been removed? And that is easy. As I mentioned in the definition, remove function only removes the first occurrence of the specific element. So that's what remove function does. So if you want to remove the 2 again, what you can do is call the remove function again and give 2 as an input. And that will remove 2 and leave you with a list which comprises of 1 and 3. All right. So then we have the pop. So you would have noticed that when we want to remove an element, we mention the item, we mention the element. But with pop, what we do is what if we want to remove an item which we only know the index of? So for example, what if we want to remove the third item? So if you want to remove the third item, we will call pop, and we will give the index of the item that we want to remove. So you can see in the what you can see in the example below is that we have popped the first indexed element. And what this pop function returns is the element that you pop. So you can see that list.pop1 has been saved as a variable popped element. And when printed, you have received the element that was removed. And when you print the list again, you will see the list without the element removed. So always remember, the pop function will return the element which is removed and edit the list. So the list will be edited and you will be returned the element that was removed. So next we have the sort function. This is pretty, I don't have to explain what the sort function does. This, it will just sort the list alphabetically. It will sort the list numerically if it's numbers, or alphabetically if it contains strings. So also, something that you can try out is uh, the reverse. So sort also has an option where you can reverse the sorting. So instead of ascending, you can make this descending. So I think I'll leave that as homework for you. So you can try to find out how to use this sort method in order to get a descendingly sorted list of elements. Okay, so now we are done with the basic functionality of lists. So now let me ask you a question. At the beginning where I was teaching you about lists, I mentioned that there are certain data types that can be contained within lists. That lists can have many different data types. So can you mention? Can you put in the chat the different data types that can be included in lists? What different data types can be included in lists? Please mention them in the chat. What are the different data types? Okay, so string, numbers, booleans, integers, strings, yes. Strings, integers, and yes, the answer that I was looking for. Lists. Something very unique about lists is that you can include other lists inside it. So, for example, if you have a list of 1, 2, 3, you can include that inside another list. You can include it as an element of another list. So that is what we are going to talk about next. And the name given for such lists are nested lists, which are lists inside other lists. So a list within another list is referred to as a nested list in Python. So if you want to keep several sets of connected data in single lists, this can be helpful. So to access an element in one of the sublists, we use multiple indices. So for example, can you see this list one that has been given to you? It's a nested list with 3 lists inside the main list. So how would we access an element inside this nested list? So what you would do is you would first find out the index of the list that your element is contained in. For example, if you want to find the index, if you want to access the element 22, first we find the index of the list it is contained in. So you can see that 22 is contained in the first list in the main list. So it's contained in the first nested list in the main list. So that list would get the index of 0. So then you check inside the list, inside the nested list. So what position does 22 have inside the nested list? So you can easily see that 22 is the first element in the nested list, and that 2 will have the index 0. So by calling the indices going from outside to in, you can easily access elements inside nested loops. So I repeat, you have to go from the biggest list to the smallest list. So first, we find the index of the nested list inside the main list, and then we go into the nested list because we have accessed the nested list by calling list one and with the index 0. So we've accessed your nested list, and then we call the index of the certain element in the nested list. So now let me ask the chat. Can you tell me the code or the line of code that I would need to call to access the element Sam from this list? What should I call? What are the indices that I should call to access Sam from list 1? List 1. Yes, I think all of you have got that correct. So very good. So Sam is located in the second nested list, and it will have that nested list will have the index of 1. And Sam is also the second element inside the nested list. So that Sam will also have the index of 1 inside the nested list. So by calling list 1, 1, 1, you will easily be able to access the list, the element Sam. So let me type just for everyone's uh, awareness, I will type the code that is necessary to access Sam from list 1. So you can see to create a nested loop, nested list, we can use a for loop, and you can see how this list has been created. Does anyone know what this range function does? Can someone mention in the chat what range function is, what the range function does? So, okay, so see. So what the range function actually does is it gives you an, a continuous number of a continuous list, or it gives you a range object which has numbers specified within the range given. So for example, we've given the inputs as 0 to 5 in for this range function. So we will receive we will receive numbers from 0 to 5 once we call this range function. So what this line of code for I in range 0 to 5 does is it calls each number which is in which is between 0 and 5. So I will range from 0, 1, 2, 3, and 4. And so these all will be appended into this list A. So this range function gives us an easy way of iterating through a certain range, iterating a certain amount of times in Python. So by using this range function, we can choose the number of iterations to do for a for loop in Python. So you can see how this nested loop has been created. You can try that by yourself. Okay, so next we move on to list comprehension. List comprehension is a much more simpler syntax. So you saw how many lines of code we have to write to just make this list, which has five, which has actually 5 empty lists inside. But there's a much simpler way to do this, and that is list comprehension. So list comprehension offers a shorter syntax when you want to create a new list based on values of an existing list. So you can see this is the method without list comprehension. So for example, you want to create a new list containing only fruits with the letter A in its name. So you can see the code for this, where we call for x in fruits, which will iterate through each element in fruits. And if A is an element of every item in fruits, it will append the fruit to the new list. But you can see this needs about 4 to 5 lines of code. And we can do this much simpler with just one line of code. And you can see the syntax which is given here. So it is exactly the same functionality. So what we do is for x in fruits, if a is an element of x, we include x in this new list. So this list comprehension is a very simple yet very elegant way of constructing lists. And it will be very useful when you are coming across different competitions, different questions, or different projects. So always remember, the syntax for list comprehension may be a bit complicated, and you may misplace the for and the in. You may mix up the for, the in, and the if, but always just have a general idea of how this happens, and it could be very easy for you to create new lists. So now we spoke about nested lists. So can someone mention, like maybe based on your A-level knowledge, what is a way, what sort of problems would be would be instances where nested lists would come in very handy for us? Could someone mention instances or questions where nested lists would be very handy? Yes, and Bueneka and Denuan both have mentioned the correct answer, and that is matrices. So matrices are instances that nested lists become very useful. So we can easily denote uh, matrices using nested lists, where each row, all the elements in one row are comprised in a list, and each row, so we have each row as a list, and the list of rows. So the list of rows will become the matrix. So we have a list of lists where the rows are a list, and the whole matrix is the list of rows. So I will show you how you can do this in the upcoming slides. So now let's move on to a quick question. So I will show the question on the screen, and you can type out the option or of the answer that you think is correct. This will be a quick question on list comprehension, and in 1, 2, and 3. Just type the option that you believe is correct in the chat below. Okay, so we have multiple answers. So first off, we have a few answers with B. So I think what the people who answered B missed out on one thing, the one way that this range function is used. So can someone mention why the people who chose B are wrong? Can someone mention in the chat? Why are the people who answered with B wrong? Yes, they forgot zero. Mahendra, Januda, they've all mentioned that they forgot that zero is given as a value of this range function. This range function returns values starting from zero if you just mention a number. So this range 11 will give you 0, 1, 2, 3, all the way up to 10. So that is where they made a mistake. The other mistake, which is not the next mistake, is not that big, but it is something that you should remember. So I got many answers between C and D. So the difference here is when Python enlists, the elements are always printed with a space in front of it. So that is why C would be wrong in this instance. So you got the logic correct, but it's just the way that Python prints lists. So since Python prints lists, with white space in front of the element, answer D is the correct answer here. So next, we will move on to the next data type, and that is sets. So let me give you an example of, let me give you an analogy, something that lists are similar to. So you can think of lists as a set of lockers in a row, each having a number starting from zero. So lists are is a set of lockers which start from zero, which are numbered from zero to the zero going upwards. So if you want to access something from this locker, from this set of lockers, you just go to the number and you can access it. You can put something inside, and that's how lists work. Similarly, you can think of sets as a bag. Sets are a bag that you can put things into, and so they don't have any order. You can't find an order in sets. So sets is like a bag. So you can't just sets are not ordered. And also another important fact to remember is you cannot duplicate items in this bag. So sets cannot contain any duplicate items, and we will see in the next slide. So a set is defined as a collection of distinct objects. They have the following properties: unordered, as I mentioned before. So they do not have any order. They do not have indexes. And if you want to access all the items, you should iterate through all of the items in the set. Then sets are mutable, which with elements, which means that elements can be changed. They're non-sequensive and no duplications. A very important feature of sets that distinguishes sets from other data types. And also elements can be heterogeneous. So I think you can, as I mentioned before, uh, sets can be thought of as a bag which you can put elements into, but they do not have any order. And by elements can be heterogeneous, what they mean is just like lists, sets can also have different data types in them. So you can have number, like you can have integers, strings, lists. You can have different data types inside sets. So you can see how to create a set. We have the set function, and you can pass in a list and into the set function, and that will create a set for you. But you can see in our second example, when you pass in a list with duplicate items, when the set is created, these duplicate items are dropped. So you only have these unique items remaining in your set. So this can be an interesting question solving path that you can take. So imagine you have a question where you are required to calculate the different number of unique possibilities that are for a certain problem. So if you want to calculate the number of unique possibilities, you can add each unique possibility into a set. And at the end, when you are done with adding everything, you will only be left with the number of unique possibilities that you added. So any duplicates added will be removed. So always remember, sets are very useful when you need to calculate, when you need to find out the number of unique items in any problem. So you can see the set operations mentioned above. So I will give you a few minutes to play around with this set operation. So you have the set add, which just adds an element. The set update will will add a number of elements. So you can see set add in the second line. It just adds 20 into the list, into the set. When you give two elements with the set add, it just adds it as a tuple. So you can see in the third line, 40 comma A has been added as a tuple into the set. But when you give set updates set update lets you give multiple values as to insert into a set. And you can see that in the fourth line, where 65 and B have been entered as separate elements. And also the set discard is something similar to list.remove. And set copy is a function that helps us to copy the elements of a set into a new set. And also in the final line, you also can see the membership check, which we had for lists, is also possible through sets. So you can see how these are done. And another thing that you can you may remember from set theory in A levels is the union and intersection. So just by using the vertical line between A and B, you can find the union of the two sets. By using the ampersand or the and sign, you can find the intersection. And by using minus, you can find the difference, while by using this triangular symbol, you can find the symmetric difference. So these are a few other set operations that you can use. So I think Buaneka has asked, are sets ordered randomly? Yes. Sets do not have any order. That's what I mentioned before. Unlike lists, sets are unordered. I hope that answers your question. So next we move on to dictionaries. So now I told you that lists are I think Ilam Purnan has, so just for your attention, Ilam Purnan has shared a Slido link. And if you have any questions, you can clarify them through that link. So just click on this Slido link and post any questions necessary. And I will answer them when time permits. So next we move on to dictionary. So I told you to, so before I told you to think of lists as a set of lockers arranged in a line. So if you want to find the locker, you can specify the locker number and go and access it. But what if you want to access your locker using your name? Well, that would not be possible using lists, because you need to know the position of your locker to access your locker using lists. Well, that's where dictionaries come in handy. Dictionaries are like lists. Dictionaries are also a set of lockers, but here, this set of lockers are arranged by their name, or in technical terms, by their keyword. So dictionaries are a data structure where which has a key value pair. So if you want to access the value of your dictionary, you just specify the key of that value. So in essence, the dictionaries are like a set of lockers, but they are mentioned, they are accessible by using their keyword, by their key. So let's just see how dictionaries work. So a dictionary is defined as a collection of key value pairs where each key is unique and associated with a specific value. So I think I forgot to mention that each key should be unique. So that is something that comes in handy. So that way you cannot accidentally access a different value than what you need. So each key should be unique, and using that key, you can access that the value that you require. So you can see the syntax of a dictionary. So I will give you just 1 minute. So maybe you can write this down. So you can type this dictionary in your personal computer, and we can try out dictionaries a bit. So I'll give you a minute. Please raise your hands once you are done typing in this dictionary in your computer. So I've shared the text for the dictionary, so we can proceed. Just save this as a variable in your Python IDE. So we can do a few dictionary related operations. So creating a dictionary. So you can create a dictionary by naming a few key value pairs. The key and value should be separated by a colon, and the key value pair should be separated by a comma. So accessing values in a dictionary is similar to lists, except that instead of an index, you specify the key of that value. So for example, in the above dictionary, you want to get the value of key 1 from my dictionary. So all you have to do is mention my dictionary, and within square brackets, you would mention the key, which is key 1. And that would return value 1, which is the value of key 1. So next, we will move on to modifying values. So you can modify the values in a dictionary, and you can do so by looking at the code given in this slide. So you mention my dictionary key 1, and you can assign a new value to it. You also, so all you have to do is mention the name of the dictionary, specify the key within square brackets, and assign a new value. You can also add a new key value pair by just doing the same, but using the new key, the name of the new key that you need. So by typing my dictionary within square brackets, new key, you can add a new value to this new key. And also removing a value, removing a key value pair is done using the pop function. And similar to Python, we type in the key instead of the index, but this pop function works in a very similar way. Okay, so I will give you a few seconds to try creating, accessing, and modifying the values in a dictionary. So I'll give you 2 minutes. Please raise your hands if you are done. So just play around with the dictionaries, just modify a value, print it, check how it works. Let me know if you have any questions. So I'll just give you 2 minutes and just raise your hands once you are done. So take a few minutes. If you're done, just raise your hand. So once again, I repeat, just please raise your hands if you're done. Okay, so I think we can move on. So if you would like to uh, continue using these sets, uh, you playing around with dictionaries, you can do so while I go through the remaining slides, or maybe after the session. And you could just post any questions that are necessary to me. So let's move on to the question. And again, just you can type in the answer for this question uh, in the chat. So you can see this question is related to dictionaries. And you can type in the answer that you think is correct. Okay, so very good. I think everyone has given the right answer, and that is answer A, which prints out the values, which are 30, 25, and 35 in sorted order, in ascending order. So yes, so I think we can move on. And this is the final data type that I will be teaching you for the day. And that is tuples, or also pronounced tuples. So how these tuples work are, they are like lists. They are very similar to lists, but the only difference is that they are, let me ask you for this answer. Can someone mention how tuples differ from lists? In what way are tuples different to lists? Okay, and the answers are coming in. Very good. Oshan, Denuan, Malminder, all of you have mentioned that tuples are immutable. And by immutable, we mean that you cannot change the elements inside a tuple after you have assigned it, after you have declared a tuple. You cannot change the elements inside a tuple. So you can see a tuple is defined as a finite ordered list. So as I mentioned, they are very similar to lists. Only difference is that they are immutable. So you can see that a tuple can be created by separating with a comma, and they can be accessed very similar to lists. So you can see that this slide mentions that tuples are list-like data structures, but they are immutable. So all the manipulation that we do to tuples are not reflected on the object itself. When we try to change its value, it raises an error. So that is something to keep in mind when working with tuples, but they can be very useful when you are working with data that you do not want to change. So data that needs to stay constant will stay constant when used in tuples. So tuples similarly to lists support concatenation, but the difference is that a new tuple will be returned. So when you concatenate two tuples together, you will be returned a new tuple. So that is something that you can try out by concatenating two tuples. And also, it is also similar to lists in the sense where you can index the elements and access them by giving in its the starting and ending indices. So I think there's not a lot that we have to do for tuples because we have already covered most of it through lists. But one place where tuples come in very handy is when you need to swap two variables together. So without using tuples, you would have to create a temp variable, and then you would have to assign one variable to the temp, and then assign that the same variable to the second one, and so on. So that would take 3 lines of code and is very unpleasant to look at. And so instead, we can use tuples, and with one line, we would just easily assign or swap the two variables with each other. So you can see below, we have a few built-in functions for tuples. Function any. So these are a few functions that we can use to get so for the all function would return if all elements in the tuple is true. The any would return if any is true. So you can look at it like the functionality in and or and or, which you learned during your A levels. So the all would be similar to an AND gate, where you would return true if all the inputs are true. And the any is something like an OR gate, where you would return true if at least one element is true. The length function is very simple. As I mentioned with lists, it will just return the size. The max will return the maximum element, so the biggest element. And similarly, the min will return the minimum. Sorted function will sort your tuple for you and return a new sorted list. Remember, it will return a list and not a tuple. And finally, the sum will sum up all the elements. This sum is also can be used with lists and is a very easy way to sum up the elements in lists and tuples. So I think we have come to the end of the learning part of today, and now we have a few interesting activities that you can participate in. So first, let's go to the question on tuples. So once again, can you mention the correct answer for this question? Just go through this and mention the correct answer in the chat. Okay, so this question seems to have a variety of answers. So I'm getting C, D, B, A. So I think you all have given me all of the answers on the list. So, but unfortunately, there can only be one correct answer, and that is answer C. So the question is, what will be the correct code for changing the tuple, name tuple 1, to only contain elements initially in the index of 1 to 4? So I think we can first off immediately eliminate answer A and B, because we are not creating a new tuple. So as you know, tuples are immutable, and just by accessing the tuple in like in answer A and B, you will not create a new tuple, and this line would be just a waste of code. So the next the solutions remaining are C and D. So you want to get the elements that contain which are between index 1 and 4. And as I mentioned, when accessing an element, you have to, while you can mention the starting as it is, the ending element, the ending index should be one more than the index that you need. So when you need the elements from 1 to 4, you would specify 1 to 5. And therefore, the correct answer here is C. Okay, so now we are going to go into a very interesting part of today's session. So here we will be answering that question, the teaser question, where we would rotate that picture. And also, as promised, we will be giving away a reload worth of rupees 500 to the person who can answer the next question. So before I put the question on the screen, please rename yourself as in the format that I put in the chat. So rename yourself with your registration number underscore first name, so we can verify uh, when giving away the award. So I'll give you 2 minutes. Please rename yourself with your registration number in front, underscore your first name. So once again, a kind reminder, please rename yourself with your registration number and underscore first name. You can a few of you have done so. So for example, let's take uh, one example here, like Ranit. So we have 664. So you can an example is this. Yes. So as I've shared in the screen, just rename yourself similarly. So I will give you another minute. So there's quite a few people who still have not renamed themselves. So please do so, as I'll be sharing this question, and you can win 500 rupees worth of a mobile reload worth 500 rupees. So please do not miss that opportunity. So rename yourself and participate in this quiz. So this is the first of many opportunities that we will provide for you at Enigma to answer questions, showcase your knowledge, and win prizes. So this is the first of many. And stay tuned with us, and we will there will be many more interesting things coming up uh, uh, in the uh, coming workshops. So yes, if you have not received, if you have not registered yet, that is not a problem. I will save your name, but okay. So I think I can. mm, Okay, so now I will be sharing the question. Also, so I didn't. Someone has mentioned that you have not registered yet. That is not an issue. If you get the answer, just put the answer on the chat, and we will. The first person to answer this question will be rewarded. So, so once again, guys, 3, 2, 1. Your question is as follows. What would be the output of the following code? What would be the output of the following code? So take your time, but don't take too much time because only the first person is going to win. So mention the letter of the answer that you think is correct. Uh, okay, the answers are coming in. And yes, and I think we have a winner, and is Sasit with registration number 198. So I think we will get in touch with you, Sasit, after the session, and we will award you with your prize. So yes, and the correct answer, which I forgot to mention, is answer B. So you can see that in this code, what happens in this modify list function is what they're asking. So first before we go to the function, let's go to this list. So you can see my list is created, and it has 1, 2, 3, 4, and 5 as elements. So uh, then we pass in this my list into the function. So uh, once we pass in my list into the function, then we uh, go inside the function. So this modify list function. So what this first for loop does is it iterates through numbers in the length of list. So length of list would be 5. So it will iterate from 0 to 4, 0, 1, 2, 3, 4. So you can see that is what the for loop does. Next, we go to the if loop, the if statement. So the if statement checks if a certain element in that list is divisible by 2. You can see that by the modulo symbol. And if it is divisible by 2, it will change the value of the list into the square number of the currently existing element. So it will change. So if a certain element in the list is divisible by 2, it will be replaced with its square. If not, you can see the else statement. If it is not divisible by 2, it will replace the element with the same element multiplied by 3. So you can see 1 will be replaced by 1 times 3, which is 3. 2 will be replaced by 2 squared, which is 4. 3 will be replaced by 3 times 3, which is 9, and so forth. And you will finally be left with the answer B. And congrats to all of you. Many of you have answered correctly with answer B. But unfortunately, there can only be one winner. We do not have, we cannot award many winners, but you will all have the opportunity to win such prizes going forward in the coming workshops. So do not worry. Many of you have got the right answer. And but the winner here is Sasit. Well, next, we move on to a very interesting application of Python. And this is where we will use everything that you have learned thus far and do the image rotation that we mentioned in your group. So anyone has any idea? Was anyone able to figure out how to do this image rotation? Or did anyone have an idea of how to do so? Okay, let's see. Did anyone have an idea? If so, can you just mention how you planned on doing it? And if you have the code, maybe you could send it to you could just mention like whatever ideas that you had in terms of solving this question. So So I think Januda has mentioned that he has an idea of how to solve it. So and also then one, yes. Yes, a few of you have the idea of how to get it. So Januda has mentioned interpret it as a matrix. So yes, matrices are the way to go for this question. But then one has also mentioned give an index to every pixel and store it in a list. Yes, but then one missed that you have to store it as a nested list. Januda mentioned interpret it as a matrix and transpose it. and reverse the order of the columns. Yes, very good. It could work like that. And yes, matrix calculation. So yes, the idea is simple. You can, let me first share my screen with you. So your question was this: how do you rotate this image? So first up, you can see that this looks very similar to a matrix. It is a 4 by 4 matrix. And what we can do is assign a number to each matrix. So each color would be represented by a certain number. So let's start with 1, 2, 3, 4, 5, 6, and up to 16. So all you have to do is rotate this matrix. So this number, this number, which is 1, would be over here. So you could do this simply with a matrix transpose and by rotating, a matrix transpose. Yes, sorry. So a matrix transpose would not exactly work. Yeah, the matrix transpose would not work because it would not give the exact image. So we want this rotated 90 degrees clockwise. So a matrix transpose would not work, but the idea of using a matrix is correct, and congrats for those who guessed it. So each cell will be given a number, and that number will correspond to a color. So can someone mention how how we would store the colors that correspond to a number? And let me give you a hint. Hexadecimal, but I'm uh, yes. But how would you, yes, everyone is saying that, okay, you can assign the number with an RGB value, but how would you store them? How would you store that this number corresponds to uh, this value? So Samihiru mentions using a tuple, but uh, this would be a bit annoying. This would be a bit time consuming, because you should remember uh, tuples or lists are zero index, but our numbering system starts from 1. So it would be a bit of a mess trying to calculate the index and so on. So I just want a simple way to map these numbers from 1 to 16 to its color using a multi-dimensional list. Yes, that the multi-dimensional list is what we use to store the pixels, to store the numbers in the pixels. We use a nested list in order to store the matrix. But I want to know how to store the colors. And the answer I was looking for was given by Vihanger, and that is dictionary. So a dictionary can easily map the number to the certain color, and that is exactly what we are going to use. So now let's move on to the code. So I've done the code, I've written the code for this in uh, Google Colab, which is a very useful and easy way for you to use, easy platform for you to use if you want to quickly write Python code. So yes, you can see my screen here. So let me first initialize. So I will initialize this matrix. Can you see this nested matrix? So I will, you don't have to really think about this print matrix and print grid. These are just functions that I've written to make it easier to visualize the transformation that I'm doing. So first, what we would do is we would print the matrix. So you can see that this matrix is how this matrix is drawn. So it's 1, 2, 3, 4, and it goes on like that. And if you can see the grid with every assigned color, so this is what the grid would look like. So I mentioned that I have saved this each color with with the number. So this 1 maps to red, 2 would map to green, and so forth. And that is done by using a dictionary. And you can see this dictionary use, which I have used here. Again, small reminder, the rest of the functions do not need, you do not have to think about at this stage. These are just functions I use to visualize for you. But look at the dictionary. See how I have saved each number and the associated color. So this helps me to visualize and show how this picture has been rotated. So now what I want to do is move this 1 over here, the 2's over here, 3 here, and 4 here. So as as mentioned before, I think I made a small mistake when I said you can't transpose, but you can do it. That actually works. So you can transpose the matrix and reverse the columns, or an easier way would be to reverse the rows and then transpose the matrix. So wait, so uh, it could go, you could do it both ways. And which would give you the same result, but actually reversing the rows is much easier when handling Python functions. But what I've done is a little bit different. So you can see, I hope you can see my rotate matrix function. So can someone mention what I've done here? What is this? This is something that we learned today. What is the name given for this line of code that I've done here? Yes, exactly. List comprehension. So I've created this final list with using list comprehension, where I assign a 0 for each row in matrix, and a j for each column. So this would look like this before I do anything to this final uh, list. It would look something like, sorry, just yes. So it will look something like this before I go into my for loop. And next, what I've done is I've iterated through this through the matrix that is passed in. So you can see that I'm passing in a matrix, and that is the initialized matrix that I have over here. And then what I do is, for every element, I call so it's a little bit of a mathematical thing here. So I get the index of the element from the matrix, and I swap it. So it is not an immediate swap, but uh, I will send you the code over so you can have a look at it and figure it out. So what I've done here is, let me show you. Final. Yes. So, uh, so you can see this is the initialized matrix and this is the final. So I want this value to go over here. So what would be the index for this one here in my nested matrix? Can someone mention it in the chat? What would be the indices, like the I and J values for one here in my initial matrix? So I was passing in that matrix here. So when I iterate, what would be the I and J values? 0, 0. Well done, Janudha. So 0, 0 would be the I and J values. And what do you think are the coordinates that I should, so my final matrix, in my final matrix over here, what would be the coordinates for this one value? Yes, 0, which means it is in the first row, and -1, which means it is the last value in the first row. So I think something that you would have to remember is that uh, you can access a list from behind by using minus. So -1 would be the last element, -2, one before the last, and so on. So what I've done is I've said that I want this the element which is 0, 0 in my initial matrix to be placed at 0, -1 in my final matrix. And that is what this code here does. So uh, for 0, 0, what it would do is I would be 0. So in uh, this matrix, in the final matrix, it would be -1, which is 0 plus 1 and multiplied by -1. So similarly, J would be 0 and it would be 0 as mentioned by Janudha. So well done. But we'll try this with another element. So can someone mention what would be the initial coordinates of number 7 here? Yes, 1 and 2. Well done. So 1 because it is in the second row, 2 because it is the third element in the second row. So now can you mention the coordinates in the final matrix? Yes, so Januda has mentioned it as 2 and -2. So it is again second row, but the second to last element. And that is, so if you plug in those values here, you will see that this line of code just gives you the values, right? So we can do the other way as well. That would be that would make the that would be a bit longer. Let's see how that would work. Mm. Yes, so you can try it the other way where you would first switch the rows and then transpose it. So maybe I could do final equals matrix matrix. So here what I'm doing is I'm switching the rows. So this -1 says that I have to go from behind and switch the order of the rows. So let's see how it looks when I put it here. So should look something like this. So you can see the first row is at the bottom, second row is here, third row is here, and fourth row is here. So let's write another function to transpose the matrix. It would be very similar. Transpose. See, the final has not changed. This would be a final. So let's see how we transpose. Uh, so we just need the final. Final. So we'll have a transpose matrix with zeros initialized, and the transpose will just be, this is a bit easier code-wise, but you'll have an extra step, but it will still work. So transpose, you just swap I and J. So let's see how that looks. Final 2 equals fix init. Mm, so yes, does it give the same values? Yes. So well done, good job. This transposing the matrix was actually suggested by you guys. So you can see I first swap the rows, then transpose the matrix. So transposing, this is the code to transpose the matrix. And then I return that, and it still gives the same answer. And now let's see the magic of our grid. So this is our, let's see the print. So we started off with this grid init. And we will end with this. Perfectly rotated by 90 degrees, done with just a few lines of Python code. And that, ladies and gentlemen, is how you can make, how you can use Python, the beauty of Python, how you can use it to make everything you do much, much easier. So I think we can move on to the question and answer session. So if you have any questions from the previous workshops or from today's workshop, or even from the question that I just did today, just let me know. We can, and I will answer them. So just maybe you can mention the questions in the Slido or in uh, in the chat, or in our or in the Zoom chat. Okay. Questions. What are the questions that we have? So someone had asked, the Fibonacci number. Is this the question? Is this the question that you are referring to? Yes. Okay. So what you would need here in this Fibonacci solver is you would have to create a function that finds the sum of Fibonacci numbers from A to B position. So uh, you should be able to calculate. So these Fibonacci numbers are numbers where let's think the nth number is the sum of the n minus 1 plus the n minus 2th number. So what you would do is you would find it would be f0 and f1 are 0 and 1 respectively. And so then what you would do is you would have a function and you could calculate, or you may even not need a function. So wait, no, you could do this with a function. So let's think you need the numbers. So you get the sum as 3 to 7. So first you have a function which gives you a list of all the Fibonacci numbers from 3 to 7, from 0 to 7, right? Because you need the first numbers to find the next Fibonacci numbers. So it would not be possible to find them without calculating the 0, 1, 2, 3, three Fibonacci numbers. So let's see. Let's try to do two integers. Equals equals int input and b equals int input. Let's run it. Yes. So I will try to get you the code because it might take a bit of time for me to also do this question. But let's see. But that is basically the gist of the question. So you have a function, you define a function, something like this, maybe def fib, and you take the upper bound, right? So you need let's see, from 3 to 7. So you take 7, right, which would be B, and then you calculate the Fibonacci numbers. So what you would do is maybe fib you save the Fibonacci numbers in a list, and maybe while n is greater than 0, to do something like so we will initialize 0 and 1. Minus 2 is greater than 0. Append this one plus fibs minus 2. So what we are doing here is we are adding the sum of the last two Fibonacci numbers into this list, and we have to subtract 1 from n, and then we will return the list of fibs, and let's call fibs and see. List is called f equals fib b, and let's print f and see if our code is working properly. Okay, I've used a bit of wrong syntax. So this would be the format of this question. Yeah, it would it doesn't take a lot of time, but uh, you could you can do this by yourself. Are there are there any other questions? Let's see. Okay. Uh, can you explain the quadratic questions from the last challenge? So what exactly was your issue, Dulasha, like when solving the quadratic question? I'll just mention that in the chat. And then there's also this enigmatic equation solver answer. Enigmatic, what is that? Uh, any, do you mean, okay, enigmatic. Okay, so I think the enigmatic question is from the first week. Uh, I'll check if I can share that later. And the quadratic one also we will check. Okay, so now this is an important question asked by Akila. So Akila has asked us, how can we get full marks in HackerRank questions, even though I write my code to get the output you have mentioned, but after submitting, there are many test cases which are not mentioned in the description that has failed. Well, this is something that all hackathons, all code problems will put you in. It is a very annoying situation, but it causes you to think. So these hidden test cases, these test cases that are not in the description but fail when you do, are known as edge cases. So these edge cases are like very specific occurrences that may happen that you may miss in a general algorithm that you write. So uh, for example, now in this fib question, right, there could be a issue where uh, let's think your sum, they ask you the Fibonacci sum between uh, 3 and 2. So 3 is the first input, 2 is the second input. And your code will have an error when you have 3 and 2. So these are like edge cases. These are cases that are out of the ordinary. So you should have checks in place to make sure that these edge cases are also adhered to. So there may be an instance where, okay, you have the Fibonacci sum is minus numbers. So stuff like that, you cannot calculate. So always uh, try to optimize your code to solve these edge cases as well. And then I don't think you should have an issue. Mhm. Are there any other questions? Any other questions? I will try to get the mm, uh, answers as well. And also, I think Dinusha has mentioned that the format for complex roots in quadratic solver question is missing. Yes, I'll try to get them to specify that. But just try with a few different formats, and I think you'll get an answer. But I'll try to clear that out within the next week. So also, well done to all of you who have done done the quiz. I think you can see the leaderboard that is put up for last week. And if any of you guys are here, just raise your hand. Just maybe raise your hand. Is Shakil Ilham here? Shakil Ilham. Just raise your hand. Shakil Ilham. No. Naveen Sandaruan. No. Hmm. Just raise your hand if even if I've mentioned it before. Situm Rana Singh. Situm Ranasinghe is here. So congrats, you've been third. So also remember that your place will be determined by how fast you do the question as well. So try to do it as fast as possible and get on the leaderboard for next week. And this is a good training for you for the final competition. And also remember that these are stuff that you will learn in your first semester of Python programming at university. And doing this will give you an edge over your peers. So keep coming for the upcoming workshops as well, and you will end up being a very proficient Python programmer, and you can solve questions that they give you with ease if you with the knowledge that we are giving you. So if anyone else is here, if Rusiru, Manodya, uh, Ransika, Hiruna, Januda, Malinda, and Yasit. If any of you are here, I mean, you can just raise your hands. I think I saw a few of you. So, yeah, Rusiru is here, Yasit, Januda, Manodya was also there, I think. And yeah, so congrats. You guys have done well. Keep doing well. And also, you will have the opportunity to showcase your talents, your skills at the final hackathon that we will organize. So also, if there are any questions, you can just let me know. And I think we can end for today. I think it was Malinda. Malinda had asked me a question. I think one of you had asked me a question at the beginning of the session. So uh, if you want to ask it again, you can just let me know and I'll answer it. And we can end for today. Thank you, everyone. You've been great. All of you were answering really well. And I hope to see you again in the upcoming session and in the final hackathon. So have a great night. See you.